Okay, welcome to this tricky little problem called Express Train. Okay, so we have London and Carlisle connected by railway lines, and we have a train starting in London and another one starting in Carlisle at the same time, heading towards the opposite station. Okay, now one of them is travelling faster than the other, and they're both travelling at constant speeds, and that's really important for this problem. Okay, now at some point in the journey they pass, and when they do, one of the trains has a further hour before it reaches its destination, and the other train has 4 hours to reach its destination. Okay, and what we've got to find out is how much faster one train is than the other. All right, now I'm going to solve this in an algebraic method, quite a complicated process. Okay, and then near the end I'm going to show you another way which could be much quicker, and we'll have a look at those two ideas and compare them. All right, so first of all, let's just look at the diagram, understand what I've done here. So I've labeled the distance from London to Carlisle as D, the distance from the point where they pass each other to Carlisle as X, and then I've put some times on. T is the time it takes this train to travel from Carlisle and this train to travel from London to the point where they meet, and that's obviously the same time. And then these numbers are the additional time that they take to reach their destinations. Okay, so I've defined all the variables here, and we're going to use S1 and S2 to represent the speeds of the two trains. We also have this little reminder about speed being distance over time. Okay, so I'm going to start with two equations like this. I'm going to say that the speed of train 1 is equal to its total distance covered divided by the total time that it took. Okay, and the total time that it took was t plus 1 hours. Okay, so that is train 1 and its speed. Okay, and for the speed of train 2, okay, I can say that that covered the same distance and the total time it took was t plus 4 hours. Okay, so that's the equation for the speed of train 2. Now, what I'm going to do next with both of these is just multiply by the denominator of the fraction. So I'm just going to times this one by t plus 1. So I get that S1 times t plus 1, okay, t plus 1 equals d. And for this one, I get that S2 times t plus 4 is also equal to d. Okay, now that's really important because it means that we have two equations both equaling the same thing. So therefore, they must both equal each other. So underneath this, I can say that S1 times t plus 1 must equal S2 times t plus 4. Okay, so I've eliminated the variable d, the distance. I don't actually need to know what that is. Okay, now we move on, and I'm going to make another expression for S1, the speed, and S2, the speed of train 2. Okay, and this is what I'm going to do. I'm going to look at the section of the journey where train 1 travelled from Carlisle to the passing place where they passed each other. Okay, and that is going to be, I'll put it here, that S1 is equal to the distance x divided by t. Okay, and we can say that S2, okay, and if we look at its journey from the passing point to Carlisle. We know that it was travelling at a constant speed. It took 4 hours to do that to cover the distance x. So S2 could be described as x over 4. Okay, that's its distance divided by the time it took. So what I'm going to do now is use these two expressions and replace S1 and S2 in here with those instead. Okay, so what I'm going to do now is I'm going to write x over t for S1, okay, times t plus 1, okay, and that's going to equal S2, and I'm going to write that as x over 4, okay, and that is t plus 4. Okay, now we're going to multiply out these brackets now, expand the brackets. So I'm going to take x over t and times it by t, which is just going to give me x, okay, and then I'm going to times it by 1, which is going to give me x over t, okay, and on this side I'm timesing x over 4 by t, which is xt over 4, okay, and for the last term in this bracket I've got x over 4 times 4, which is just x, because the 4's cancel. All right, now if you look at those two expressions either side of that equals sign, they both contain an x and an x, a plus x and a plus x. So I can just cancel them out. I can just take x from both sides. So I'm left with xt equals xt over 4. Okay, now xt equals xt over 4, so I'm going to write that over here. So I'm just coming up to here now, xt, okay, x over t rather, equals xt over 4. Okay, it's getting a lot simpler now. And what I'm going to do now is I'm just going to notice there's a common factor of x in both sides. So I'm just going to divide both sides by x, and then I get 1 over t, okay, equals t over 4. Okay, now if I do a process commonly called cross multiplying, times both sides by 4 to get rid of this, and times both sides by t, I get 4 equals t squared, okay, and therefore t equals 2. Okay, so t equals 2 hours. And now I know that, I can see that the total journey for train 1 is 2 plus 1, which is 3 hours, and train 2 is 4 plus 2, which is 6 hours. Okay, so I'll just make a note here. Train 1, 3 hours. Okay, train 1, 3 hours, and train 2, 6 hours. Okay, now from that we can conclude that one train is twice the speed of the other. In fact, train 1 is twice the speed. So 1 is twice speed of 2. Okay, so that's my conclusion from that working out. Okay, now just to finish this off with, I'm just going to partition this off. There is a much easier way which appears to be quite logical. Okay, and if we just look at this diagram and we consider ratio and look at the times, okay, and we notice that this line here that divides at the passing point. We have 1 on the left and t on the right. And because the trains are going at constant speed, we can also see that we have 2 on the left, t on the left and 4 on the right. So we ought to be able to say, because they're both traveling at a constant speed, that the ratio either side of this line must be the same. Okay, because the only variables are the time and the speed. The distance is fixed. Okay, that doesn't change. So what we're actually saying is the speed is inversely proportional to the time. In other words, if you double the speed, you halve the time, and so on. All right. Now, if we go by ratio, we would simply say that the ratio of 1 to t, okay, must equal the ratio of t to 4. Okay. Now, to get that to happen, the ratio we need is 1 to 2 equals 2 to 4. Okay. And I think you'll find that argument is quite secure, because it's based on a very visual representation where we can see the boundary, if you like, between the ratios where the two trains pass. So 1 to t has to equal to t to 4. So it's 1 to 2 and 2 to 4, because that's the only value of t that would cause those two ratios to be equal. Okay, I think the solid method here is very thorough and very algebraic, and there's no doubt that that leads to the correct answer. But there's an alternative method which is much quicker and a good use of ratio. Okay, that's it.